Hello, everyone, and welcome to Bookercast, the podcast where books come to life.
And I'm so excited to dive into another amazing story with all of you.
Whether you're a bookworm or just love a good story, this is the place for you.
Every episode, we explore incredible books, talk about their stories and characters, and share insights that'll make you fall in love with reading all over again.
All right, let's not keep you waiting any longer. Get comfortable, and let's jump right into it.
Sounds good.
Welcome to our deep dive into Michio Kaku's Parallel Worlds.
Oh, this is going to be fun.
It is, right? It's a wild ride through the universe, the multiverse, and maybe even beyond.
Yeah.
So if you've ever looked up at the night sky and just wondered about, what's out there, what's our place in all of this, this is the deep dive for you.
Definitely, yeah. I mean, what's fascinating about Parallel Worlds is that, Kaku tackles these huge questions, but he does it with such clarity and enthusiasm. He doesn't just throw dry facts at you.
Right.
He takes you on a journey through the history of cosmology. He highlights the aha moments.
Yes.
And even, the embarrassing missteps along the way, So it's really cool.
I love that. I love that he does that too. It's kind of like getting a backstage pass to the world of theoretical physics.
Absolutely.
And one of the things that struck me was how he starts the book talking about his own childhood fascination with these two kind of contrasting views of the universe.
Yeah, I remember that, yeah. He talks about this early interest in the Buddhist concept of an eternal universe, timeless.
Right.
Juxtaposed with the Judeo-Christian idea of creation in a single moment,
Yeah.
And it's interesting because it kind of mirrors the tension that has existed within scientific cosmology itself, right?
Yeah, absolutely. For centuries, limited data has led to some pretty wild theories.
Oh, for sure, for sure.
Remember that time scientists calculated the age of the universe to be younger than the Earth?
Oh, yeah, how embarrassing is that?
Talk about a major scientific oops.
Right. It's a great example of how our understanding evolves, though, right?
It is.
We got to be willing to challenge assumptions and embrace new evidence,
Right.
even when it leads to uncomfortable revisions.
Yeah. Speaking of uncomfortable revisions, what about Newton's clockwork universe?
Oh, yeah.
It seems so elegant, right?
Yeah.
But it had some major problems. Can you remind us what those were?
Well, for one, there was Bentley's paradox, right?
Yeah.
So, if the universe is infinite and full of stars,
Right.
their infinite gravity should pull everything together, cause a massive collapse. So why isn't everything imploding?
Right. And then there's Olber's paradox, which asks, why isn't the night sky blazing with light if there are infinite stars?
Exactly, yeah.
It's like asking, if the universe is a never-ending sea of stars, why is it so dark at night?
Yeah, it's a good question. And these paradoxes, highlighted the limitations of that Newtonian model.
Yeah.
And kind of forced scientists to seek out, new explanations,
And it's so interesting how, Edgar Allan Poe, the master of the macabre.
Oh, wow, I forgot about that.
Yeah, he proposed that, the universe might not be old enough for the light from all the stars to have reached us yet.
That's wild. Edgar Allan Poe, the poet.
Yeah, the poet, the short story writer. Yeah.
I had no idea he, dabbled in cosmology.
I know, it's kind of a, fun fact, right?
That's so cool.
And his intuition, while not totally accurate, did kind of point towards this idea of a universe with a finite age.
Yeah.
A concept that would become, central to the Big Bang Theory later on.
Right, exactly.
And then Einstein comes along and, revolutionizes everything with his theory of relativity. Right?
Yeah.
It's mind-blowing to think that he showed that gravity isn't just this force.
Right.
It's a warping of space-time itself.
Totally changes your perspective.
Yeah.
Yeah, and those insights, really paved the way for the Big Bang Theory, which, explains the origin of the universe as this massive expansion from this incredibly hot, dense state. But even the Big Bang Theory, had its own set of mysteries to solve.
It did. The evidence for the Big Bang itself.
Yeah.
What was it that convinced scientists that this wild idea was actually plausible?
So one crucial piece of evidence came from the WMAP satellite, which captured this baby picture of the universe when it was just 380,000 years old.
That's amazing.
It's amazing. And this image, often called the echo of creation, it revealed tiny temperature fluctuations that provided strong support for the Big Bang model. Like, we got a peek into the universe's baby
I
album.
love that analogy.
Yeah.
So through this cosmic snapshot, we know the universe is about 13.7 billion years old,
Yeah.
right? But here's what I find really intriguing. Kaku talks about how most of the universe isn't made up of the stuff that we're familiar with.
Yeah.
And enter dark matter and dark energy.
Exactly. So the WMAP data, along with other observations, revealed that those familiar atoms, the stuff that makes up you and me, everything we see, it only accounts for about 5% of the universe.
What?
Yeah, crazy, right? The rest is this mysterious stuff called dark matter and dark energy. We can't see it directly, but we know it's there because of its gravitational effects.
It's like realizing that your house is mostly built with materials you can't even see. So what's the current thinking on what these mysterious substances actually are?
Well, that's one of the biggest unsolved mysteries in cosmology today.
Really?
Yeah. We know dark matter exerts gravity, but it doesn't interact with light or other forms of electromagnetic radiation. And dark energy is even more bizarre. It seems to be causing the expansion of the universe to accelerate.
So the universe isn't just expanding, it's expanding at an ever-increasing rate.
It is, yeah.
So doesn't that mean everything will eventually end up incredibly spread out and cold?
Yeah, that's the current prediction, which is the scenario known as the Big Freeze.
The big freeze, huh?
Yeah, it's a bit of a chilling thought, isn't it? But, even as we were, figuring out the Big Bang,
Yeah.
there were these two brilliant and often clashing personalities, George Gamow and Fred Hoyle,
Okay.
who are both, really central to our understanding of how elements are formed.
Okay, back up a little bit. Who were these guys?
Uh-huh.
I'm getting a sense that the history of cosmology is full of these larger-than-life characters.
Oh, it totally is. So Gamow was a huge proponent of the Big Bang,
Okay.
and even had this kind of whimsical nickname like the Cosmic Jester.
Oh,
Yeah, and Hoyle, on the other hand, hated the Big Bang idea.
really?
Yeah, he came up with this steady state model,
Okay.
which proposed a universe that was eternal and unchanging.
Oh, interesting.
Yeah, and he actually coined the term Big Bang sarcastically, but it ended up sticking.
Oh, the irony. Okay, so how did these two guys contribute to our understanding of how elements are made? I mean, isn't that like a completely different field of study?
It's all connected. So Gamow's work on Big Bang nucleosynthesis, it explained how the lightest elements like hydrogen and helium,
Yeah.
were formed in the intense heat of the early universe.
Okay.
And Hoyle, despite his aversion to the Big Bang, he made, groundbreaking discoveries about how heavier elements are created in the cores of stars through a process called stellar nucleosynthesis.
So even though they disagreed on the origin of the universe,
Right.
they both contributed to our understanding of how the elements that make up everything around us came to be.
Exactly. It's a great example of how science progresses, through debate, through collaboration, sometimes even a bit of rivalry,
A
right?
little healthy competition.
Yeah, totally. But even the Big Bang Theory, as successful as it was, it still had some puzzles to solve.
There were still some wrinkles in the fabric of the universe, so to speak.
You could say that, yeah. Two big ones were the flatness problem
Okay.
and the horizon problem.
Okay. I have to admit, those sound a bit technical. Can you break them down a bit? Why should I, as someone trying to understand the universe, care about these problems?
Sure. So think of it like this. You bake a cake, right?
Okay.
And somehow, every single part of that cake, even the edges, are perfectly cooked and at the exact same temperature,
Right.
even though, they haven't touched each other.
Magic cake.
It's like magic cake, right? It's as if something ensured that heat was distributed perfectly evenly right from the start.
Okay, I'm intrigued. So how did cosmologists resolve these seemingly impossible problems? Do they just throw their hands up and say, the universe is weird, let's move on?
Well, that's where Alan Guth
Okay.
and his mind-boggling theory of inflation come in.
Inflation, like the economy. How does that apply to the early universe?
So Guth proposed that, in the first fraction of a second after the Big Bang, the universe underwent this period of exponential expansion. It ballooned in size
Wow.
at an unimaginable rate, and this rapid expansion would smooth out any of those initial irregularities
Okay.
and explain the uniformity that we see in the cosmic background radiation.
Okay, so I'm trying to picture this. So it's like blowing up a tiny wrinkled balloon to the size of a house, and suddenly all those wrinkles disappear and the surface becomes smooth.
Exactly, yeah. Inflation solved both the flatness and the horizon problems in one fell swoop.
Wow.
But, even inflation wasn't the end of the story. It needed some refinements,
Okay.
which led to Andre Linde's concept of chaotic inflation.
And that's where we start venturing into the realm of multiple universes, right? Things are about to get really wild.
Hold on tight. So Linde's model suggests that big bangs could be happening all the time.
All the time.
With universes constantly budding off from other universes, like it's a mind-blowing picture of like an eternally inflating multiverse.
Okay.
Where even if individual universes eventually die out, the process of creation just never ends.
Whoa, okay, my head is spinning a bit. So if universes can just pop into existence like that, where does all the matter and energy come from?
That's where it gets even weirder. Kaku explains that a universe might be able to come from nothing because the positive energy of matter and the negative energy of gravity could essentially cancel each other out.
So they balance each other out.
Yeah, and this makes universes incredibly cheap to create from a cosmic perspective. It's like the universe is running a buy one, get one free deal on universes.
Universes for free. That's just, wow. Okay, we need to take a moment to process this. We've gone from a clockwork universe to an ever-expanding multiverse in just a few minutes.
I know, it's a lot.
It is a lot.
Yeah.
But let's talk about those other universes.
Yeah.
What are they like? Are there infinite copies of us out there living slightly different lives?
That's a great question, and that's where we'll dive into the truly mind-bending stuff.
Okay.
Parallel universes and higher dimensions. And Kaku doesn't just speculate wildly, he connects these seemingly outlandish ideas to, like, rigorous physics, like Einstein's theory of general relativity and the bizarre world of quantum mechanics.
This is where I think the learner in all of us gets really hooked.
Right.
Like Kaku's able to bridge that gap between complex scientific concepts and our everyday understanding.
He really does.
So where do we go from here? What are some of the key takeaways from this first part of our journey?
I think the biggest takeaway is that our understanding of the universe is constantly evolving.
It is, yeah.
What seems like a settled fact today, could be overturned tomorrow by new discoveries. And as we delve deeper into these mysteries of the cosmos, we're forced to confront questions that, kind of blur the boundaries between science and philosophy.
It's a humbling reminder that even with all of our scientific advancements, there's still so much we don't know about the universe and our place within it.
It really is.
But that's what makes it so exciting.
Exactly.
So join us for part 2 of this deep dive, where we'll explore the even stranger world of parallel universes, wormholes, and the possibility of time travel.
Can't wait.
Welcome back to our deep dive into parallel worlds. Last time, we explored the Big Bang, the expanding universe, and that mind-boggling concept of a multiverse where universes are, like, constantly being born. Now things are about to get even weirder as we venture into the quantum realm.
Oh,
I'm already feeling a little dizzy.
you and me both. The quantum realm is notoriously strange, even for physicists. But Kaku does a fantastic job of, explaining how quantum mechanics adds another layer of complexity and possibility to the idea of parallel universes.
So before we go any further, can you remind me, what makes quantum mechanics so different from the physics that we experience in our everyday lives?
Okay, so in the classical world, the world of Newton, everyday experience, things behave in this predictable way, right?
Okay.
You throw a ball, you can calculate its trajectory,
Right.
you know where it's going to land. But in the quantum world, things are fuzzy, uncertain. It's all about probabilities.
Yeah.
Possibilities.
It's like the universe can't make up its mind. And I remember Kaku uses that example of Schrödinger's cat to illustrate this.
Yeah.
Can you remind me how that works?
Okay, so Schrödinger's cat is this thought experiment where you have a cat in a box,
Okay.
along with this device that has a 50-50 chance of releasing a deadly poison.
Right.
And until you open that box and observe the cat, it's considered to be in a superposition of states, both dead and alive simultaneously. It's only when you make an observation that the wave function collapses and the cat becomes definitely one or the other.
So the act of observing something actually determines its reality.
Yeah, pretty much.
That's so counterintuitive.
I know, it's crazy, right?
Yeah.
And it's one of the most fundamental and mind-boggling aspects of quantum mechanics. Now, apply this to the universe as a whole.
Okay.
What if the universe itself is in this constant state of superposition,
Okay.
with all possible outcomes existing simultaneously?
And that's where the many worlds interpretation comes in.
Exactly. The many worlds interpretation proposed by Hugh Everett III takes the idea of superposition to its ultimate conclusion. So it suggests that every time a quantum measurement is made, every possible outcome actually happens, but in different branching universes.
So there's a universe where Schrodinger's cat is alive and well,
Yeah.
and another one where it, well, isn't.
Right.
And there are infinite versions of ourselves out there making different choices, living different lives.
Could be.
My brain is officially fried.
It's a lot to process, I know.
Yeah.
But Kaku explains it in a way that's like both mind-bending and strangely compelling, you know?
Mm-hmm.
It raises questions about free will, the nature of reality, and the very meaning of existence.
Okay, but if there are all these other universes constantly splitting off, why don't we see them?
That's a great question.
Yeah.
And it gets to the heart of how physicists are trying to like reconcile quantum mechanics with our everyday experience.
Yeah.
One idea that Kaku explores is called decoherence.
Decoherence.
Yeah.
So those other realities are somehow out of tune with ours.
That's a good way to think about it.
Yeah.
So decoherence suggests that interaction with the environment, even something as small as a collision with an air molecule, causes the wave function to collapse
Okay.
or decohere into a definite state. So those other possible universes, while still theoretically existing, become essentially invisible to us. It's like each universe gets its own radio frequency, and we're only tuned into one.
So even though all these possibilities are out there, we're only experiencing this one specific branch of reality. I'm starting to see why quantum mechanics gives even physicists a headache.
For sure, yeah. It definitely pushes the boundaries of what we thought we knew about reality.
Absolutely.
Yeah.
But going back to that earlier question about like infinite copies of ourselves, what do you make of that? Does the idea of the many worlds interpretation diminish your sense of free will? Or does it make you feel like the possibilities are endless?
Honestly, I'm not sure. You know,
Yeah.
it's a bit unsettling. Like,
Yeah.
if every possible choice is being made in some alternate universe, does that mean our decisions don't really matter?
Right, exactly.
You know, I mean, if there's a version of me out there who won the lottery, why am I still stuck in traffic?
I feel that. I think that's that philosophical dilemma that Kaku's getting at.
Yeah.
Like, he doesn't necessarily endorse the many worlds interpretation,
Right.
but he presents it as this serious scientific possibility.
Yeah.
One that forces us to reconsider what we mean by like free will,
Yeah.
consciousness, the nature of self.
It's a lot.
It's a lot. But Kaku doesn't just stop at exploring the multiverse. He goes a step further and asks, could we escape our universe if we had to?
Oh, right.
Now we're really going down the rabbit hole.
I know. He introduces the Kardashev scale, which classifies civilizations based on their energy consumption. So a Type I civilization can harness the energy of its entire planet.
Okay.
Type 2 can control the energy output of its star.
Wow.
And Type 3, like a truly mind-boggling civilization, can command the energy of an entire galaxy.
Wow, that's a lot of power. But how does this relate to escaping our universe? Is Kaku suggesting that we could just like pack our bags and move to another universe if things get too rough here?
It's not quite that simple,
Yeah.
but he speculates that a Type 3 civilization with its unimaginable technological prowess, you know, might be able to manipulate space-time itself, potentially creating wormholes or even, like, birthing entirely new universes.
Okay, that's officially beyond science fiction at this point. But I do appreciate how Kaku grounds these speculative ideas in actual physics. So back to wormholes. I mean, aren't those just theoretical constructs? Could we actually travel through them?
That's where things get really tricky. So wormholes, as predicted by Einstein's theory of general relativity, are essentially tunnels through space-time,
Okay,
connecting distant points in the universe.
so like cosmic shortcuts.
Exactly.
But Kaku also mentions some pretty serious dangers associated with wormholes.
Yes,
Like,
even if we could create or find a stable wormhole, you know,
right.
the gravitational forces involved would be immense. We're talking about tidal forces that could, like, rip you apart at the atomic level.
Yeah.
And then there's the question of where you might end up. You could emerge from a wormhole billions of light years from home, or even in a completely different universe.
That's a pretty risky proposition.
It is, yeah.
And what about that whole time travel paradox? Wouldn't going back in time create all sorts of like logical inconsistencies?
Well, the possibility of time travel is one of the most, you know, fascinating and controversial topics that Kaku explores. He discusses different types of time travel, from traveling to the future, which is theoretically possible,
Right.
according to Einstein's theory of relativity, to traveling to the past, which is much more speculative, and raises those, you know, paradox problems that you mentioned.
Like going back in time and accidentally preventing your own birth.
Yeah.
Talk about awkward family reunions. But how does this tie back into the idea of parallel universes?
Okay, so one way to resolve the time travel paradox is to invoke the concept of parallel universes.
Okay.
If you travel back in time and you change something, you might not be altering your own past, but rather creating a new branch of reality, a parallel universe where that change occurred. It's like the universe has this built-in safety mechanism to prevent paradox.
Okay, I think I need a flow chart to keep track of all these branching timelines and alternate realities.
Mm.
So what are some of the most, intriguing what-if scenarios that Kaku proposes when it comes to manipulating space-time or, escaping our universe?
One mind-blowing possibility he discusses is like the idea of transferring consciousness into another universe.
Whoa, like a cosmic upload.
Pretty much, yeah.
But wouldn't that require a level of technology that's, beyond our current comprehension?
It certainly would, yeah. We're talking about a civilization that's mastered not only the laws of physics, but also like the nature of consciousness itself.
Right.
And Kaku presents it as this like last-ditch effort for a civilization facing, the inevitable heat death of its universe.
I could see how that would be a powerful motivator.
Right.
But wouldn't transferring your consciousness into another universe essentially be suicide? I mean, would that even be you anymore?
That's a deep philosophical question. It gets into the nature of identity, consciousness, what it means to be human.
Right.
And Kaku doesn't shy away from those questions. He acknowledges the immense risks and the ethical dilemmas involved, but he also presents it as like a testament to the human spirit's drive to survive
Yeah.
and explore.
I'm starting to see why Parallel Worlds has such a wide appeal.
It's really good.
It's not just a science book. It's like this philosophical exploration of humanity's place in the cosmos.
Absolutely.
So where do we go from here? What other, mind-bending concepts does Kaku throw our way? Welcome back to the final part of our deep dive into Michio Kaku's Parallel Worlds.
It's been pretty wild, right?
It has. We've covered so much ground: the Big Bang, the multiverse, wormholes,
Yeah.
even the possibility of escaping our universe.
It really is a book that stays with you, even after you've finished reading it.
It does.
Kaku's enthusiasm, it's infectious, It really leaves you with this, profound sense of wonder.
It does, yeah. And one of the things that struck me was how he just so seamlessly blends cutting-edge science
Yeah.
with these big philosophical questions. It's not just about equations and theories. It's like we're grappling with the meaning of existence itself.
Absolutely, yeah. He doesn't just shy away from the implications of these mind-blowing concepts. Like, what does it mean for us?
Right. Yeah.
Who are we? What's our purpose?
Yeah.
Especially in a universe, or a multiverse, I guess, that could be teeming with other universes.
Another life, yeah. So let's talk about meaning. If our universe is just one of many, does that make our existence any less significant?
I mean, does it make our lives meaningless? It's a big question.
It is a big question.
And Kaku tackles it head on, He explores all these different philosophical perspectives, from the Copernican principle, which suggests that, we're not at the center of the universe, to the anthropic principle, which says that, the universe's laws and constants seem fine-tuned for the existence of life.
Yeah, and the anthropic principle always makes me wonder, is it just coincidence
Right.
that we're here? Or is there something more?
Yeah. Is there some deeper meaning, like a grand design behind it all?
Right, exactly.
The million-dollar question. But you know what? Kaku presents both sides.
Yeah.
He doesn't really endorse any one particular idea. He acknowledges the possibility of a multiverse arising from purely physical processes.
Right.
But he also leaves room for the idea that, there might be something more at play, something beyond our current scientific understanding. It's like he's saying, hey, we don't know everything.
Yeah, I love that about his approach. He's a scientist.
He is.
But he's also willing to acknowledge the limits of science and, embrace the mystery of the unknown.
Absolutely. Which brings us back to meaning, Even if our universe is just one of many, even if there are infinite versions of ourselves out there making different choices, Kaku argues that our individual lives still matter.
They do.
We have a choice. We can choose to create meaning, to build connections, to strive for something greater than ourselves.
I love that.
Even if our universe is just this tiny speck in this grand cosmic tapestry.
Yeah, it's a very powerful message.
Yeah.
And I think it resonates with a lot of people. People who feel overwhelmed by the vastness of the universe.
Right.
And our seemingly, insignificant place in it.
Yeah.
But it's not all about philosophy, though, is it?
No.
Kaku also talks about, the the potential impact of these ideas
Yeah.
on, like, the future of cosmology.
Yeah, our exploration of the universe. Like, could we find evidence
Oh, yeah.
for other universes?
Yeah, that would be incredible.
Right, maybe through like subtle variations in the cosmic microwave background radiation,
Sure. Yeah.
Or even through like the creation of microscopic black holes in particle accelerators.
Okay, now that would be a game changer.
Right.
Imagine the headlines, "Scientists discover evidence for parallel universes." It would, like, completely revolutionize
It would, yeah.
our understanding of reality.
Totally. And it would just open up all these new avenues of like scientific and philosophical inquiry.
Right. It'd be really cool to see that.
It would.
He also discussed, the possibility of future civilizations, like developing technologies that could allow them to manipulate space-time, create wormholes.
Or even escape to another universe, if ours becomes uninhabitable.
Yeah, it sounds like science fiction.
It does.
But Kaku's point is that these possibilities, they're grounded in theoretical physics,
Yeah.
even if they're, far beyond our current technological capabilities.
Yeah, parallel worlds really pushes the boundaries of our imagination, but it does so with respect for the science. And I think it just captures this like sense of awe
It does.
and wonder about the universe.
It does. I have to say, this deep dive, it's been incredible. Parallel Worlds is a book that challenges us to think bigger, to expand our concept of reality, and to embrace the unknown.
I couldn't agree more.
And I think, for all you learners out there, if you're ready to have your mind blown and to embark on this, unforgettable exploration of the cosmos, I highly recommend adding Parallel Worlds to your reading list.
You won't regret it.
It's a journey you won't soon forget. And that brings our deep dive into Parallel Worlds to an end. We hope you've enjoyed exploring these mind-bending concepts with us. And remember, keep questioning, keep learning, and keep looking up at the night sky with a sense of awe and wonder. Until next time, stay curious.
And that's a wrap for today's episode of BookerCast. We hope you enjoyed diving into it as much as we did. Thank you so much for spending your time with us. Your support means the world, and we can't wait to hear your thoughts on this episode.
Don't forget to subscribe, hit that like button, and share this episode with your fellow book lovers. And let us know your thoughts in the comments below. We love hearing from you. See you in the next deep dive. Bye for now, and happy reading.